In this tutorial, I'm going to demonstrate how to do an isometric drawing based on the question provided in the Grade 10 JP Engineering Graphics and Design workbook, and this example comes from page 50 in the workbook. Now let's start by looking at the question and what has been provided to us. In the question it says the front view and the top view of a model in third angle orthographic projection has been given. This is our top view and this is our front view, and we'll just determine where that comes from just now. And then it says the position of point A on the drawing sheet is also being provided. So this is very important that is starting point A for the start of our top view when we look at it in an isometric perspective. And then this is the point A, which is the starting point of our front view on our 2D views. Now the 2D views are placed in this orientation because we see our projection symbol is a third angle orthographic projection symbol. I've just drawn a very quick example of a 2D orthographic diagram. Now this diagram is used to help us understand the layout of our views when it comes to 2D orthographic views. And there we see that our top view is over here, front and right view over here. This is our y-axis, this is our x-axis, this is our z-axis, and this is the 45-degree mirror line. Now this 2D orthographic diagram helps us to understand the layout of the views as they are provided to us in our question. So if we were to draw the x-axis between the top and front view, we will see that will correlate with this x-axis that's between the top and front view. The right view has been omitted. It has not been given to us in the question, but there's more than enough information given from the top and front view that we can use to now go and draw our 3D isometric answer. Let's read the rest of the instructions. Convert the orthographic view of the model into an isometric drawing, which is what we already determined. And then make A the lowest point of the drawing. So this point O, which is the starting point here in our top view, and our front view will be our lowest point where we will start from in our 3D isometric answer. And then we do not have to draw any hidden detail. Obviously, you are welcome to go and draw in the hidden detail afterwards if you like. However, this is not a requirement for this drawing. Now, if we go to our drawing page, I've drawn an A4 page here. Although I know we need to draw in an A3 page, I just used this to make the drawing a bit larger and more clear to see in our tutorial. So I started by drawing a line here on the page where I'm going to draw an auxiliary view. Now the auxiliary view is what I'm going to use to accurately determine the starting or the edges of each one of these corners of my pentagon on the pentagonal prism at the base. That's a hexagonal prism at the base, and then the pentagonal, my apologies. It's a pentagonal prism at the base and a pentagonal pyramid resting on top of that prism. And that's what we want to draw. We want to draw that pentagon first. Now, I already drew the pentagon on the inside, on the right here, to its measurements and scale. And I'm going to show how to now use the tip of this to correlate with the pentagon that is part of the prism, the outside pentagon, that we want to correlate that tip with the inside or the center of our prism as well, so that it looks similar to what we have here on our top view in the question. So let's start. Now obviously we see that the pentagon has a base of 40 millimeters, and therefore we are going to use a method where we're going to take our compass and construct this whole pentagon using only our ruler and compass, and we're going to have our compass set to 40 millimeters throughout the whole construction. So I'm going to start by placing my compass on either end of this given line, and I'm going to draw it to 40 millimeters, or stretch it to 40 millimeters and draw a light construction circle, and then the same from the other end, draw a light construction circle with 40 millimeters as a radius, and then I'm going to draw a vertical line straight from there all the way through to the intersection on the other side, and I'm going to extend it indefinitely. So this intersection to that intersection and extend it indefinitely. We will determine the correct length of it just now. But it's important to note that those intersections are perfectly aligned with this vertical line that I just drew. And then what I'm going to do is I'm going to take my compass once more and I'm going to draw another circle with a radius of 40 millimeters, which obviously will end on the tip of that line and the other end of the line. And then I have that circle here crossing and intersecting with the two previous circles. The reason why I need that is because I'm going to draw a light construction line with my ruler now from this intersection right through this intersection here. And this is very important, not to draw it through the baseline, but to draw it through that arc here at the top. And if I've done that, I can extend that line all the way till it intersects or cuts through this circle on the edge here. And we will do exactly the same from the left through that point. And then we're going to extend that line all the way to the edge of this circle. I just want to quickly draw in the rest of my arcs with light construction circles, and just to make it look proper. So I'm going to draw one there. I'm going to draw one here. Obviously on paper you will just draw the circles as far as you need them, and you will never exceed the edge of your border of your page. Good, so I'm going to cut off those just now so that I do not exceed the border's edges. That is very important. Let's see if I've got them all. I can erase that arc over there. Sorry, the excess over here. Now I'm going to clear all those constructions. There we go. So now I do not go over the edges of my border, and I haven't erased any of the constructions that show how I got to my answer. Good, so what we want to do from here is just complete the pentagon. So we're almost there. We've done the majority of the work. So where the diagonal line came through this point here, this intersection right here, and this diagonal line came through there, we had, that is very important, that is the heart of our construction. If you didn't do that correctly, your pentagon's layout will fail. So therefore we have made sure that that is correct. So what I want to do now again is from here, from this intersection, also draw an arc with a radius of 40 millimeters, because we said we used the same 40 millimeters right throughout. And then from this intersection on the right, also a radius of 40 millimeters, using that same radius all the time. And now I can cut off the parts, the excess constructions that I do not need, and I can delete them. So on paper you would just not draw it further than where it's needed. Good, so here on CAD I'm using my tools, and therefore I need to do some housekeeping. Good, so once we've done that, we now actually have all 5 points for our pentagon. So I'm going to go and select my line tool. I'm going to make it part of my answers layer, make it solid lines, and draw in the outer edges of my pentagon. Once I have drawn the outer edges of my pentagon, I can now go and determine the center of my pentagon. Now, if I want to get the center of the pentagon, I'm going to have to halve two angles of my shape. Now, you can go about this several ways, but I like to go and use the two corners here on the base itself, that where I started from. So I'm going to just use now, and this might now have a lot of constructions. However, you will see soon how helpful this is. I'm just going to use for the demonstration of this tutorial 20 millimeters as a radius. You can use anything as long as you keep your compass to the same radius. I also describe this and have separate lessons on this in my channel, where you just have to draw one of these constructions at a time. and therefore I've just made those two circles now, both with a radius of 20 millimeters. You could have just gone and done this first one by yourself like that. Let's do it like that. So 20 millimeters. I keep the compass to the same radius. So what I now have is I just created a reference point here on this base side and then a reference point on this base side. That's why I just used that 20 millimeter radius on my compass. What I was actually looking for is, now this was the construction of how to halve an angle. So now I'm going to go from that angle that I wanted to halve and where those arcs intersected with one another. Now there's a lot of arcs here. Maybe I should just change the color of those two arcs. So I started with this arc that I drew first, and then I drew this arc, and then I drew that arc. Let's just make them another color to make them stand out. And where they intersect with one another, I just drew a light construction line. I'll just change that to a light line. And then I'm going to extend the length of this line now to anywhere past the middle, past this vertical line, in other words. Now I'm going to do the same on the right hand side. So let's just from the start use a different line color. I'm going to go and say that's 20 millimeters. Because I use 20 millimeters, I'm just going to keep my compass on the same radius, 20 millimeters again, both sides. So on this line and on this line, where those interact with one another over here, I can now go and draw another light construction line from that corner to there, and then just extend it on your paper. You would just have to extend it all the way anyway. Still where the two diagonal lines intersect with one another. If you worked accurately, they will perfectly align on that vertical line that we constructed earlier on for the pentagon itself. And that will be the heart of my pentagon. That will be the center of it. And now I can just go and draw in solid the pyramids lines as I see it from the top. But at this stage, I'm not going to do that. I just want to leave it as it's shown here, and then I'm going to get rid of all of these constructions. Now you will not delete these constructions on your drawing because you need to prove how you got to your answer, but for the sake of this tutorial and to make things clear, I just want to delete those so that there are a little bit less arcs in the way. Good, so but we know this is our center point. Now if we want to, we can draw in light but not dark these lines to show how they got from the edges of your 5 corners to the center. They will be exactly the same length if you worked accurately. That will be the tip of my pyramid. But now obviously we drew the prism here. We just wanted to get that center point so that when we take this pyramid, which is the inner pyramid, this part here, so if we took that pyramid and align it up with the prism center, that they overlap perfectly with one another. And so I'm not, for the sake of the time, going to redo the pentagon. You just now saw how to do it. But what I'm going to do is I'm just going to go and select this. So obviously you could draw this now on the side of your page as well when you did your construction for this pentagon. But I'm going to just drag it across here and place it here on the center point of our prism. And there we go. Now we have all the constructions. I'm going to hide all of them for the sake of this tutorial. So let me do this. And then things are a bit clearer and more visible. Good. So if we take these lines away, we see the exact layout as of our top view that we see here on our question. So that's our auxiliary view, which is the same as our top view. Now the reason why we needed this is because we want to now take these measurements that are now drawn to scale 1:1 and carry them over onto our isometric answer. Now when we do this, we first have to go and what I call is do the boxing of this outer pentagon, the prism, and that is by drawing light construction lines vertically and horizontally on the edges of my pentagonal prism as it's given here. So therefore I'm just going to go and draw very light construction lines that are right against the base edges, around these edges over here on the sides, and then the tip here, and then I can clear my constructions, and then you see there I've now boxed that whole pentagon prism, the outside pentagon, and I'm just going to send that now to the back so that we can see the outlines of our prism solid. So remember, the outside is our prism, the inside is our pentagonal pyramid, which is resting on top of that prism base. So why did we need to do that? Because we need to now go and determine point A and see how that relates to our answer and how we're going to use that for our dimensioning that we're going to carry over onto our 3D answer. So therefore, I'm going to do the right thing. I'm going to just label, let's copy that label over there, and I'm going to label this here as point A, as our question also clearly states. So we know that's corner A, that's over there, seen from the top. So what we want to do is now use on our paper those exact distances from A and carry them over. Now you can go ahead and do an even better thing, and that is to number each one of these corners. And maybe I should do that now for the demonstration of this tutorial. So I'm going to go and label each one of these corners. I'm going to start with this one as 1. And I'm going to go clockwise and label them in a clockwise direction. There are people that do not like to label or number their corners. I always advise that you should. It will help you so that you do not get confused. And for the sake of the tutorial, it will also be easier to use these reference points when we do the discussion. There we go. And then lastly, I just like to always label my tip, and that's a capital letter T. So there we go. Those are the ones we can focus on. We do not need to name or label the inside corners, but if you want, you can go ahead and do so. So now, using those reference points from A to 1, from A to 5, and so on, we're going to carry those measurements that we take here on our auxiliary view and carry them over onto our 3D isometric answer. Now, the tool you will use for this is the divider. So that is the one that looks like a compass but has just 2 sharp metal tips at the end of or at both ends, and that's the divider. So what are we going to use? That's the most accurate tool to use. You can use your ruler or your compass, but the divider is the suitable tool. Now, as all of you should know at this stage of the drawings, is that when you draw an isometric drawing, from the starting point we always have to draw base angles at an angle of 30 degrees to the left, as well as a base angle of 30 degrees to the right. And then we normally also draw a vertical light construction line. Now these, I just used my water lines in TurboCAD to start with the layout. Obviously these will now just be drawn light construction lines on your paper. Good, so what we want to do now is, because we know this is point A, that's the same as point A over here, we're going to literally measure with our divider the distance from A to 1 and the distance from A to 5. So from A to 1, this is now for the base pentagonal prism, and therefore I'm going to just make sure my tools are set right, and I'm going to measure exactly from A to number 1. On TurboCAD, we are very accurate. We can say 32.6 millimeters. Obviously, you would just take the distance, which will be 32.5 millimeters with your divider on paper. And I'm going to say 32.6 from A to 1. So we know we are moving from there left. Right, from A to number 1, we're going to go left. So I'm going to go and say, now I've forgotten the distance, 32.6 if I'm not mistaken, 32.6. Always double check. No harm in checking. It's a lot of harm if it's wrong. tab 32.6. So I know that from here, and if you wondered what this part is here on the right hand side, I just use this when I'm drawing on CAD so that I can easily get my reference points and just plot them. Okay, so that will be number 1, and I'm going to copy and paste that label so that it's very easy for you to follow along. And then I can clear those construction lines. But for the time being, I'm going to leave it because, oh wait, let me just draw it quickly. Just make this a bit clearer. I'm going to draw that line and then extend it a little bit. This is going to be the just my x-axis on the left hand side because it's third angle, and this is going to be my z-axis to the right, which is for the depth of my drawing in third angle. And then I can also just draw, if I want to, the vertical construction line just a little bit up here. I just need a little start for it, and then I can clear all these water lines. There we go. Now it looks a bit more like yours on paper. So we now measured from A to 132.6 millimeters. Now we want to go, that was from A left. Now we're going to go from A to the right hand side to the z-axis over here, and we're going to measure the distance over there. And that is a total of 23.2. On paper it will be 23 millimeters from A to on the z-axis. Oh, I forgot again. Double check rather to make sure it is 23.2. 23.2. And then we can plot our dot. And that we know is going to be number 5. Remember, this is now on the base of our pentagonal prism that we are going to measure that. And then we can clear our constructions. On paper, you would have just measured that with your divider and labeled. I advise that you label it as soon as you've plotted the reference point. Good. So obviously, if you were to look at your isometric drawing, then now corners number 3 and 4 would not be visible. Well, 4 will be visible, but 3 will not be visible. 2 might be visible when we draw the base of our prism. However, I'm going to draw the whole shape of it, and I advise you to do the same. And there are several ways to go about that now that we have these 2 points. Now, if you agree with me, 5 and 2, they are aligned with one another, parallel to this box's edge. So 5 and 2 is perfectly aligned. 4 and 3 is perfectly aligned. Nothing aligns with number 1 except the tip, which is in the middle or the center. So, but for what it's worth, I'm going to now use my ruler and draw parallel to the z-axis for what it's worth, an indefinite length. It doesn't have to be any specific length, but at an angle of 30 millimeters. And then I'm going to go from number 5 and draw parallel to this line here, a line indefinite length, like construction lines. And I'm going to make that now also 30 degrees just to the left. And I know then number 2 is going to rest somewhere along that. And but before I go along with that, let me just finish now the box. So from A, I could say this is B over here. So let's maybe call that B for what it's worth. I'm going to call that corner B. So from A to B, that is moving from A left towards B on the x-axis. So I'm going to measure that distance now from there to there, and it's exactly 65.2 millimeters. On your paper it would be 65 millimeters. So I'm going to measure 65.2, and I'm going to plot another dot right there, and then I can clear my construction. So now I know B is right here. And I hope you notice everything I draw is light construction lines. So I'm just planning my layout of my pentagonal base. And the next distance I want to do is, now you can go anywhere in any direction you would like, but let's just label every one of these outside corners so that we can use them as we go along. That's C, and we will call this one D. So from A to D, I'm going to measure that whole distance. Now, it will not be the same as A to B. A to B was 65.2 millimeters. From A to D, using our divider as a measuring tool, will give us 61.1. Why? Because this is a pentagon. It's not a symmetrical shape in that orientation. Octagon would have had a perfect square. Hexagon would have had a perfect square around your shape, but in this case it's a pentagon, so it's now 61.1. So from A on the Z-axis, meaning that we're going to go to the right hand side here in third angle, it's 61.1 to the right on the Z-axis for the depth, and we're going to plot that measurement right there on that base length and clear our constructions. Once we've done that, we have done quite a bit, because now I can actually just go and again draw a parallel line. So I'm going to be very naughty and use my parallel line tool here on TurboCAD. Now, obviously, you can use your set squares on your paper, but I've now demonstrated how to get the rest easily. So let me cheat a little bit here. Using the functionality of TurboCAD, and all CAD software has this ability, most of them. And then I can do some housekeeping, getting all of those lines neatly aligned. I call this housekeeping, where I now get rid of all the excess lines. Okay, so make sure you zoom in. If you're drawing on CAD, please, very important to make sure to zoom in so that you make sure you got those connections exactly how it is. We are professionals. We must do a professional job. So forget about this vertical line here. We'll get to that in some time. But this now is literally just the layout of that box. I drew it because I still want to get corners number 2, 3, and 4. Now 2 already is actually determined, so I can just go and copy 2. 2 is literally just on the opposite side of where I had number 5. As you can see here, 5 and 2 is aligned horizontally, so it will be aligned here on this axis, the x-axis, on my isometric answer. And therefore now I can just go and determine either number 4 or number 3. It's your choice which one you want to use. I'm going to go from D, measure 2, 4, and that's 12.6 millimeters using your divider. So we know this is D. Okay, let's do the proper thing. Let's call that the corner that it's supposed to be. Let's just do C as well. Let's do our job correctly. So D is over here, C is over here, and I know there's many teachers that might be watching this saying that there are shorter ways to do it. That's perfect. I'm doing this as people that start now from scratch and from the start. So we've got D, and I think this was 12.6, that's right. So from D inward, it's going to be 12.6, and I'm going to go and grab a dot, and again, yes, we won't see that in the background, but as I said, we need to do this proper. Well, we actually will see number 4, to be honest. And then obviously, if D to 4 was 12.6, C to 3 will also be 12.6, because this is exactly the same distances from the edge or the corner. So I'm going to go from there, say 12.6, and then I'm going to grab another dot as a reference point and plot that right over there. And now I want to also plot for number 2 so that it doesn't feel lonely. Go and plot that over there. and then I can go and clear all my constructions. Good. And there we have it. We can now actually draw the light layout of our hexagonal base. Now this is the lower end of my base, so nothing here is solid. Okay. If you get more advanced, you will see which lines can actually be drawn solid, but for the sake of the guys who do this for the first time, let's just draw everything light construction lines, which is the wisest thing to do at the start till you start to get the hang of these drawings. So there I have gone. I've made point A as the lowest point of my pentagon. So now what I do is I'm going to say to myself, there is the outline of the lower end of my prism. Now this prism obviously doesn't just lie flat on the ground. It is protruded or extruded 20 millimeters upwards. So now I can start making use of this vertical y-axis that I have drawn here. So now I know all of these 5 points that I have now projected is going to go 20 millimeters up. Now just realize I haven't numbered number 3 and 4, so let's do the proper thing and label them as well, so that we can easily refer to it in our discussion further on. Number 3 and number 4. There we go. So 1, 2, 3, 4, 5, all of them is going to go now 20 millimeters lifted off the ground, so that we have that prism with a height of 20 millimeters before we can even start with the pentagonal pyramid. So, but that's an easy job to do. So what we want to do is we're just going to go and draw, and I like to do this light as well. Some will do it solid lines from the get-go, no problem. I just like to do the planning all in light construction lines. So I'm going to go and draw that 20 millimeters vertically up from every single one of those corners, because I have determined them now on my very low base, but now I want to just protrude that or extrude that 20 millimeters up from every one of those corners. And that's what I love about technical drawings, is that we can actually use our methods in different ways. There's more than one way sometimes. As long as you get to the correct answer and you follow the correct rules, then there are several ways to get to the same answer. Okay, good. So now this is starting to look like a prism that is starting to be lifted off the ground, and all that I need to do now is just connect all of those ends with my ruler, so I can literally just go and draw those. Some of them you can draw in solid. These two from number 4 to 3 obviously will not be solid, and from number 3 to 2, because they will disappear with the pentagonal prism or pyramid, sorry, that is going to be in, resting on top of this prism. But there we have the prism. Now you can go ahead, draw in solid the edges and lines that you would like to draw in solid now if you want, but I'm going to leave it as light construction lines just for the time being, and soon we will start to draw in the solid lines to show which parts are the actual answer. So I'm going to just save my work up to this stage. And now that we have the pentagonal prism, we need to find now the center of that, and to do that we need to make sure that we also have now obviously are going to determine that on this top of the prism, which is 20 millimeters lifted off the ground. So number 1 would be the logical place to use and measure to get to the tip the quickest way. Remember, we want to work against time. So from number 1, this distance to the tip of my line, that distance is going to be exactly 33.4 millimeters if I use my divider to measure from number 1 to the tip. Now that's on the ground level, so that's 33.4. So let's use that, because I already have drawn a line here that I can use. So it was 33.4. Let me just double check, always double check 33.4, that's correct. On paper most likely either 33 or 33.5. Okay, so I'm going to measure from there 33.4, and that will give me on this light construction line that runs through the middle, which is the same as this line. Obviously I just haven't drawn in this a line from number 1 to the tip. Let me just show you. It would have been as if it was running all the way through to there. Okay, that is now this line coming from number 1, but I'm going to erase that because I don't need that over here, but I need it over here, and I've now determined that lower point. The right thing to do is to go and grab a reference point and plot it there, and then get rid of that water line. They always bother me when they're in the way, but they are very useful. Okay, and then from that intersection I'm going to go up again exactly 20 millimeters. Yes, there are many other ways also to do this, so I'm just using this as a method. Okay, 20 millimeters straight up, and that will be the exact middle or center on the top of my pentagonal prism. Good. Now let me just tell you what else you could have done. Now the same as with the base that you did this kind of square, it's a rectangle actually. You could have now gone and drawn that now here at the top as well, and then gotten the center using your auxiliary view. But the method I used here is because I have already got a number 1, I just took it up 20 millimeters, knowing what the distance is from number 1 to the center, which is then obviously from number 1 here to that center. Just take it up 20 millimeters. Now I have that reference point, which is the center. Now what I can do is parallel to these lines that are 30 degrees to my left, I can go and draw a center line. Well, I must actually, and then also parallel to the lines going on the z-axis to my right, I can draw a center line. So that's what I'm going to do next. I'm going to use my parallel line tool, and I'm just going to draw on the z-axis a guideline, which I'm going to use nano, and then here on the x-axis I'm going to use a guideline, and then I'm going to draw another guideline just so that I can end off my center lines at some distance. So, and then I'm going to draw, let's draw this one here. I will fix the length just now, do it proper. Just want to draw it. So that's my z center, my z axis or center line, and my x axis or center line there. Let's clear all these constructions. Now yes, you will see it's not proper center lines yet, but let's change the properties of that line. On paper you will obviously go and draw those center lines in proper from the get-go. I'm just going to go and change them now. That's a nice thing of drawing on CAD. I hope you all start to love to draw on TurboCAD or AutoCAD or any CAD program for that matter. They're all great. I love them all. So what we do is, obviously, if you're old school like me, I always teach my students to extend your center lines past your reference edges. Yeah, that's very important so that we do a proper job. So maybe I can take it up there. Good. Now we have proper center lines running through them. Now center lines are actually medium tone, so I'm just going to change them then from there to a gray. Yeah, so it doesn't look too dark. But anyway, so there we go. We've got our center lines. Now you will see the purpose of these center lines just now, and but we know that those center lines are resting now on the top of our pentagonal prism. So from there, I'm going to determine corner 1 here. Let's say that's the inside one. Yeah. So the inside one, which is going to be to the inside of number 1 here, somewhere along there is where I'm going to measure number 1. Now the best play is, because we already have the center, which is here on our auxiliary view, we're going to measure from there to number 1, the inside number 1, and carry that over. So let me go, use my measuring tool from the center to there as 25.1 millimeters. You will have it as 25 millimeters on paper. So here's number 1, so that's corner number 1. So from the center, from there towards the edge of number 1, I'm going to go say 25.1, and then I'm going to go and do the right thing again and plot that dot. There we go. You can label this number 1 now if you want as well, or something else. If you want to go now 6, 7, 8, 9, 10, it's your choice. I'm just going to leave it as it is, being a little bit naughty. Okay, so from the center to there is number 1 on the inside, which is this corner here. And then what we want to do is we just want to see how can we now get numbers 2, 3, 4, and 5 over here. Now, this is where it helps to have at least a center point or a reference point to work from. Now, again, we can now go and draw a box on the edges of that inside pentagonal pyramid. So this time we are working with the pyramid's outer edges, and that's why I go and draw a box in there. I'm going to use a different color just to help you to see the difference clearly. Draw that box which touches the edges of every one of those corners of my pentagon. Once I have that, I'm going to go edit, clear all constructions, and there we go. So let me just move that also to the background just for what it's worth. Let everything just stand out that has to stand out. So let's move the constructions to the back. Okay, good. Now my pentagonal pyramid's base is solid and in front. Okay, so now what I want to do is exactly what I did with my outside prism of the pentagon, where I drew the box ABCD. I've done now that with the inside. This time I am going to label it, because otherwise things are going to get very confusing very quickly. So let's just go. I hope it's not too confusing already. I'm going to make it lowercase a. Going to put that there, going to say copy paste that label, and go and carry on same direction there. I like to keep going in the same direction, chronological direction, if you can call it that. So this is going to be C. So I'm going clockwise in this case. You obviously, as I said before, can go anti-clockwise as long as you keep it chronological. That's the key. Okay, and then I'm going to go and label the last one D. There we go, lowercase. So why did I do that? Well, we had this number 1. Let's go and help you with the numbers here as well. And I'm going to name this one number 1. Let's just change the color to blue. Let's use, blue. Okay, so you can see that's the inside number 1. So from that number 1, we have this line that goes parallel to AB's box edge on the outside, now parallel to that on the inside. So that means this line here, which is AB, we're going to go 30 degrees on our x-axis in third angle. So therefore, it's the same as if I were, let's just go and copy that number over there. If I were to go now through this number 1, which is this line AB, lowercase ab, going through number 1, if I were to go parallel with that 30-degree x-axis, I'm going to go and do the same over there. Through number 1 at an angle of 30 degrees, cannot be anything else other than 30 degrees. I can now go and measure from number 1 to my left, from number 1 to my right, the distance here. So from number 1 to the left to B, from number 1 to the right to A. And they should be the same if all my measurements were accurate at the start. So let's see, that is perfectly 24.5 millimeters. So I'm going to carry that over from my number 1 here, 24.5. Sorry, now I forgot again. Let's go back and check it. Double check, my friends, double check. It's always best. It's 24.5. Okay, still with it. So from there, tab 24.5. And there we go. There I have measured now on this 30-degree x-axis, the 24.5. So what I'm going to do is just draw that same light construction line from here to there. And I'm zooming in CAD. On paper, you will basically end up on exactly the same as that line that I've drawn there already. But let's just go edit, clear all constructions. There we go. Now, any good draftsman, again, will go and plot a dot there. But because I already have so many dots, I'm going to just use small little dots. I've got some small dots hiding away here. A little bit sneaky, but I've got them. There we go. Let's just copy that one and paste it and just go and plot it here on the very edge of this line. Look at how I zoom in every time. Please do that. It's a good practice. Okay, so now we know that that was 24.5 millimeters from number 1 here, which is 24.5 millimeters from here to there on my auxiliary view as well. Okay, now I think you get the idea. So from A, I can now go and measure that distance to the inside 5, and from B to the inside corner of 2, and then I can do the same with C to the inside corner of what is 3, and from D the inside corner of what is 4. Okay, so let's go and do that. So I'm going to start with A, and I'm going to measure from that corner to 17.4 millimeters. So from A on the, I forgot to go and draw a parallel line there. My apologies. So I've got some war going on with a fly flying around here at the moment. So let me just focus again. So 30 degrees now to the right, which is my Z axis. And then also 30 degrees here from number 2, right from there. And I'm going to go 30 degrees to the right. That means I can now also go and carry over that distance. Oh, I forgot it already. That is 17.4 millimeters. So I'm going to go from this intersection tab 17.4 millimeters. And I don't have to measure it on the other side if I don't want to, because it's parallel across. It's going to be the same, but anyways, let's do it. 17.4, and then let me go and plot those small little dots there. That's going to be on that side, and its counterpart on this side. That is the intersection, and then I can go and clear. Oops, not yet. I first want to go and draw a light construction line for my box over here to there and just carry it on. I'm just going to use that line, cheating a little bit here now. So from here across all the way, we're going to extend it to the right left. Now edit, clear all constructions. So now let's do something before this bugs me too much. I'm going to first go and label that corner number 2 on the inside. Let's use the right color. So let's do it so that it is clear to everybody. It's effort, but do it. It's worth it. Do this one, number 5 on here. It's fun. Drawings are fun, so no effort really. So paste. That is going to be inside 3. Now, as I said before, you can use this as any numbers, as long as you get a system that works and that correlates logically with what you are busy doing. So I'm just using color now to differentiate between the outside and inside corners to make things easier on you. So we now have 5 and 2 plotted here, very small, but it's there on our hexagonal prism's top. And so we're going to just use the base of our pyramid now and carry those 2 labels across and plot them down here. Sorry for all the moving around on the screen. I'm trying to do this as quick as possible. There's 5. Let's go to number 2. There we go. There's number 2. So we've got 1, we've got 2, we've got 5. Now, just to prove to you guys I wasn't cheating when I said that number 2 and 5 is parallel to one another, let's use the parallel tool, and parallel to the x-axis, we're going to go and plot. Just take the snap on. There we go. Let's see if I worked accurately. It's going exactly through number 5's intersection there. And look at that. They're exactly through number 2. So we are going in the right direction. So now I can go and clear all those construction lines. And now the wise thing would be to get the distance from B to C and from A to D. To do that proper, we actually only need from one of them. So I'm going to go measure now from A to D. Remember, this green box is the extent, or the box that goes around the edges or corners of my inside pentagonal pyramid. So that's what that is for, and I use it as reference for measuring. So 45.9, you will most likely have 46 millimeters on paper. So 45.9 for me on CAD. I like to use the right measurements on CAD. So 45.9 from here, tab 45.9, and that gives me the reference point over there. Now I need to get one of those small points again, go and plot it there on that extent, and that will give me that corner. I'm going to do housekeeping, make sure it is exactly to there, and I can actually extend this line and take it to where it goes there. Now if I worked accurately, that point and the one here on the far right should be perfectly aligned if I use my parallel line tool. So let's just go and check that out from here, from the intersection right there. Oops, I was lying to you. It's to that one. Sorry, I got the wrong one. Let's just extend that line. So there we go. And if I worked accurately, this line's length should also be the same. So let's just double check that I didn't do anything wrong. Never, no harm in checking yourself. Never ever, no wrong in that. So 45.9, perfect. As we've got that, so we can just now draw that line from C to D over here, and that gives us A, B, C, D of our box around the pentagonal pyramid's base that we have carried over here from our auxiliary view. I hope you are still following me. Good, so once we have that, we can now go, and obviously we have done number 1, number 2, number 5. Now we can either use now corner C and D and go and measure now from D to 4 or from C to 3. That's your decision. I'm going to go with D to 4 here on the right hand side because I can see it, it's visible. So 9.5 millimeters on the dot. So let's go here to D. And we're going to say tab 9.5 millimeters, and I'm going to go and plot that dot. Whoops, forget that. So copy that corner or dot first, paste it, and just plot that there. So that was 9.5. Now we can do it from the other side. I see I'll need to. So tab 9.5, and I'm going to go and plot the dot. Now that I've got that, come on, grab it. There we go. Okay, and then I can clear those construction tools. Good. And now, proper thing to do, label. Label, label before we carry on. Always the wise thing to do. Carry those labels across to where we need them. Plot them. In CAD, it does sometimes, it's a little bit of a hassle to label. That's the only part that I do not fancy as much, but it's important. So now we have 1, 2, 3, 4, 5. I want to emphasize, if you look closely, number 1, number 2, 3, 4, and 5 are all perfectly on the edge of that box that we carried over from our auxiliary view. So this green box that we got, we carried over here from 2D, which is our auxiliary view, to 3D, which is our isometric answer. So, and we started with number 1 as a reference, and then we worked our way around and get all the other points as we have discussed. So, but please make sure that those edges are perfectly on, or those corners are perfectly on the edge of that box that we do the actual rectangle. Good, so once we have that, you can now decide how you want to go about it, but I'm going to go and draw once again the pentagon's shape. So the base of my pentagonal pyramid on there, I know you're not going to see 2 to 3 on your answer, but a good draftsman will do the right thing and draw it in because it's actually there, just not seen, it's hidden. And then from there to 5, let's snap perfectly, and then all the way back to number 1. Good, so there we go. Now we have a lot of lines, right, and a lot of dots, a lot of labels, but we will see our 1, 2, 3, 4, 5, back to 1 layout of the base of our pentagonal pyramid resting right there on top of the top of our pentagonal base of our prism. Good. So all that we need is now the tip of our pyramid. Now you will agree with me the tip is perfectly 90 degrees above this point that we determined, and that's why I like to use the method that I did, because we can now just from this reference point where the x-axis and the z-axis of our center lines meet with one another, go 90 degrees straight up to the height that is given to us in our question, which in this case is 50 millimeters from the base of the top of our prism to the tip of our pyramid. So, or you could have said right from the base of our prism, the bottom end, from the ground level up 70 millimeters. Okay, but I'm just going to use this 50 millimeters because we already have determined this point here, and from there 90 degrees up at a distance of 50 millimeters as our question shows. And now we're very close to the end. So what I'm going to do is use my construction line from that center point, go and draw an indefinite line. I first just draw it up, all the way, any distance, 90 degrees straight from that point upwards. And now what I need to do is measure that 50 millimeters that my question tells me from the top of the base of my pentagonal pyramid, or the bottom or base of my pentagonal pyramid, whichever you want to use. And then I'm going to go from the tab 50, and that will give me the tips distance. And I'm going to go and drag one of these dots, copy one, and drag it all the way to that intersection. So, and there I've got it. Now I can do the housekeeping, get rid of the excess lines, which is these, to the tip there. And I can erase these water lines. Good. So now again, from here all the way to the tip, 50 millimeters. Now once I have that, the rest is very easy. The question said that we are not supposed to show any hidden details, so we're not, but we're going to now draw in the actual solid lines for our answer. So I'm going to go and change it now to solid lines. And what I want to do now is look at the corners that's going to be visible from the base of my pyramid, which is resting on the top of my prism. And I'm going to just drag them all the way to the tip of my pyramid. But let's just label that tip so that we know where we're going, to Mount Everest at the tip. And so what we want to do is from the base, go, I will see number 1, I will see 5, I will see 4, I will also even see number 2. It's just number 3 that's all by its lonesome. So from number 1 all the way up to the tip, solid line. You can draw this in solid now. And from number 2 all the way to the tip. Make sure I zoom in all the time. Make sure that I get those connections right and proper. Do it proper on your paper as well, please. Good draftsman, always make sure. And then from number 5 I took, number 4 we will see from the exact point all the way to the tip. There we go. And then we can now go and draw in those solid lines here as well. I can either just draw over them like you would do on paper, or I can select them on CAD, doesn't matter, and just make them change their properties to solid, doesn't matter. I'm just going to draw over them like you would do on paper. Please no double lines, please just keep your line work neat and tidy. Make sure that you don't see double lines when you do this now over those construction lines. And now what you will see solid, you will draw solid here till it disappears. Okay, on paper yours will most likely look like it's almost on that center line, but you look closely in CAD where we draw 100% correct, you can see there's actually a little bit of distance and depth there. Let's just draw all of these edges of the top of our pentagonal prism as well to bring out those lines. That's the right way to do. Remember, all outlines are always solid in all drawings. So it disappears from here behind. So we're not going to draw in those hidden details. Then we will see all of these edges solid on our pentagonal prism base. It's a bit of a tongue tie between the prism and pyramid. Mix that up sometimes. Okay. Especially if you have both of them in one drawing. And there we go. Oh, there's almost two lines. Let's just zoom in properly. Yeah, on your paper it most likely will also look like that exactly. And then this one here. And there, my friends, there we go. That is the conclusion. Let's just zoom out a little bit. Get everything nicely fit together. First, we went through our question. We discussed the principles of why the question is orientated the way it is because of the third angle projection symbol. Then we went and we drew our auxiliary view of the pentagonal prism and pentagonal pyramid. Got the square box around each, well, not a square box, rectangular box in this case around it, from where we would have done our measurements. And then we have just carried over all those measurements here from 2D to 3D on our isometric drawing, and we end up with a very nice looking pentagonal prism base with a pentagonal pyramid resting on top of it. Obviously you could have added some more labels if you wanted, but this is sufficient for your answer. Thank you for your time, thank you for watching, and I hope you enjoyed the tutorial. Have a good day.